how long this repeating string is. I guess the way to do it maybe is to check every length up to n over 2. So potentially do something along these lines where we say start, check every string size, every substring size 1 to n over 2. Because if it's bigger than n over 2, we know that substring can't be repeating because there's just no space for it to. VS Code is telling me to restore my session contents from 1:20 a.m. yesterday. Ah, gosh, okay. So, we check grab substring, check if it... So, I guess the question is, right, like if we have like cat, 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 dog, this is not considered a repeating string. So we need to also grab the substring if substring length mod by, if s mod substring length does not equal 0, meaning the substring that we're looking at can't be evenly divided into s, it's false automatically because there's just no way that it can do that. Otherwise, we just set up a for loop with a pointer to go through it. Alright, let's see what the next question is. Zero matrix. Given a two-dimensional matrix of integers, for each zero in the original matrix, replace all values in its row and column with 0. This is where it becomes a challenging problem, because there's no way to do it in place, I don't think. Because the only way to do it in place in this array, I think, is to utilize another data structure to store where the 0 coordinates were, which I think is just more inefficient. So I think it's going to be just that, where we make second n by m matrix if not equal to 0, so if it's not equal to a 0, we copy the number, else just replace row call in new matrix with 0. Easy. Is there any constraints regarding time and space? There's no constraints. Matrix is, 100,000 by 100,000. Maybe it does want us to do it in place. Try that in place with 01 extra memory. I don't want to. 01 extra memory, huh? How do we store where the zeros are? It's a great question that I don't have an answer to. Well, let's try it not in... Given a root to a binary tree, return whether it's symmetric. Ooh, this is weird. Hold on. This is a weird one. Okay. Because you can't just check for symmetry at every level. You have to check. Yeah, I'm not quite sure how to tackle that, so we're going to go ahead and move back. So let's do repeating string first. Int I equals 0. 1, actually I is less than s dot length. Cool. String cur sub is equal to s dot substring from 0 to I. We just got to make sure that here we do s dot length over 2 to avoid having to check the whole other half that we know won't work. If s dot length mod the cur sub dot length does not equal 0, it's not evenly divisible, we break looking at anymore. Okay, let's do this. We should see curse sub incrementing every step. So D and dog. Okay. Now, the curse substring here is dog. So, once we get to dog, we're starting sub pointer at 0, I pointer at 0. Let's do this real quick. Less than 3, right? And let's print out this comparison. We should see DDOOGG. Why are we seeing... Oh, that's just giving us the remainder. What if we do this, right? If subpointer that should have worked. Is equal to curse sub dot length. Fine, I'll just do it this way. DDOD DDO. Okay, dog. DDOOGG. Good. That works. What we can do here, I think, is to say, after incrementing both of these, say if I pointer is greater than or equal to s dot length, return true. It's kind of a tough batch of questions. A little bit surprised. False. So, DDOD, that's false, it goes through. Okay. Breaks after that statement. DDOOGG, cool. Now, let's do s dot length. Yeah, fine. Just let it run the whole thing. Nice. Let's just cut out our printlns here. Nice. Okay. Weird that over 2 plus 1 should fix it. Yeah, a little bit faster. Okay. Definitely not the fastest way to do it, but I definitely wouldn't start from 0. I think the best way to approach this would be to adjust the start rate so you start at where you finished last time all the time, because you know that everything before it either worked or really didn't. All right, let's, I guess, do this one. So let's keep a pointer to the dictionary that we're in. Dictionary pointer equals 0. Int s pointer is also equal to 0. So what I want to do is to, first of all, I need to store all of these characters in a set, probably. What's the topic here? I guess the way to do it is, I wonder if it's faster to store them in a set and then go through and check then. I kind of want to try my way. You know what? Let's try this. While s pointer is less than s dot length, we're gonna go ahead and just do that. Let's do s pointer plus plus always for now. And let's return true. I hate these questions that don't involve like a data structure that you just need to know how to use. These are just pure logic, which I guess in one hand are good to practice, but also are very frustrating when you're so used to So I guess the idea here, right, is to say, hey, let's keep track of a current character. Cur equals just an empty character for now, right? This question just sucks. Finally starting to wake up from the coffee. Okay, so we have that. Now let's say if s dot contains s dot char not s dictionary. So if dictionary contains s dot char at I, right? Here's what we're gonna do. Couple things need to happen. So if s.char at I does not equal the current character that we're looking at, we need to do one thing. Else, if it's the same character, s pointer plus plus. Don't care. What we need to do is, first of all, update the current character. So update current character. If it is not in the dictionary, we do not care. Then, what we need to do is to say, hey, is it in the dictionary? If it is, We do not care. If it's in the dictionary, does it appear past as the next car we are looking for? Are we guaranteed to have okay. All right. The question I guess I have. So if it's in the dictionary, what we need to do is increment our dictionary pointer until we find it. Right? There we go. Move dictionary pointer up till we find it. If we can't, that means not sorted. So while dictionary, yeah, it's hard because it's purely logic. While dictionary.care at our dictionary pointer does not equal s.care at I, we are going to move that pointer along. If dictionary pointer is greater than or equal to dictionary.length, so basically if we reach the end of the dictionary without ever finding that character, we can return sweet. Congrats. Okay. Does it appear as the character? Okay, cool. So if it appears in our dictionary, we move up until we find it, then we stop. Okay, I was gonna say I'm impressed if it criticals care at S pointer. The one thing I noticed is I kept utilizing like my own kept using the wrong names for things in the Microsoft interview. There you go. Okay, let's run it. Does not compile. Line 29. Goodness. Okay, we're gonna get there one day when I fix all of my compile errors. And then we'll get to see another one right here. Oh, wait, what? Okay. I just kind of... methods and get used to them. Still working on a Notion page for it. Yeah, it's one of those things where I use Python for these. Okay, that's 2 down, 0 matrix. Okay, what I'm thinking here is to built-in methods and listen strings and writing down the useful ones. Hey, that's sweet. That's a really good way to do it. How can we do this? How can we do this in O of 1 space? Okay, there has to be some sort of algorithm we can apply, right? Where we maybe recursively do it. Maybe recursively, yeah. So if we start off, let's say at the top here, we find a 0, we recursively go down its row, updating every row here. Find a 0 here, recursively go down, find a 0 here, recursively go down. No, but I mean, we'd have to do like, not even tail recursion. Tail recursion's bad here. We want it to be like, up, like, we want all the recursive stuff to happen at the very end. Because I think the best way to really do it, like the super cheap and easy way, is to just, again, just have another matrix. But, okay, I'm gonna try and solve it without the other matrix, okay? Let's do that. Matrix, let's do int. Call it result. New int array of matrix.length. Matrix 0 dot length. Okay. So we're gonna just iterate through the original matrix. Alright, so we're gonna do the same thing the other dimension. I shall always be a square matrix, so we just do 0. Alright. If matrix I j does not equal 0, we're going to just copy that value in. Great, okay. What are the topics? Hash table. Hash table? What? Well, see, okay, well, that doesn't make sense because if you're utilizing a hash table, matrix and 2 zeros. I guess it could be the hash table is like a fixed size, maybe, because it's gonna be only n. Then 15 minutes. Yeah, it's not gonna be easy. At least not the intended way. Alright, so otherwise... Zero int k equals 0. K less than, so we need the row. The row is I. Okay, we're gonna do K, and then from K, what do we have to do? Alright, so result at k j is equal to 0. This will actually fill a column. Let's do matrix at 0, and let's do, here we're going to replace this one with a k, this one with an I. And I think down here should be able to just return. Sweet. Wrong answer again. Wow. It continues to fill. We replaced it with a 0, but I mean, I don't really know what to do then. So, in place modification, right? It's labeled as a hash table question. How can we apply a hash table to this? My best guess would be storing a because okay, O of 1 space, I assume a hash map. Okay, let's try this. I'm gonna do a map of lists. Equals a hash map. Gonna make one of these bad boys, okay? What we're gonna do is we're gonna store a row, and then list of calls with 0. This will allow us to do one n squared traversal, or rather n times m traversal. After doing this traversal, we know exactly where these are. Then we iterate through the map and replace every row and column we see with a 0. Is that faster? Probably not, but it's worth a shot. Okay, so let's go ahead and set this up. Really wish I didn't like delete my for loops. That'll take too long to set up though. Let's copy this loop. paste it in here. Cool. Replace this with a J. J, 0, J. Great. So every step here we need to do map.put I new array list of integer. My slice magic has failed me. Yeah, number 2 is kind of tricky. Alright, so we have that. We're going to say now if matrix I j is equal to a 0, okay. So if it's a 0, we're going to add j to list I. Map.getI dot add j. We're going to add the j. Okay, yeah, I mean, it looks to be O of one space. Meg. Okay, so we're gonna add that. So I guess now we can go through and we should be able to do. Okay, let's try this real quick. For list integer for int I in map.keyset. System.out.println I plus, and let's do a map.get I.toString. So this will allow us to first of all see if we're getting the behavior that we're expecting. Compilation error. Why won't you compile? Oh. Oh, yeah, that's on me. That's on me. Wrong answer, but we have a at 0 index 1 and index 2. No zeros, index 0, index 1. Sweet, okay. What we're gonna do now is to say, we're gonna need another one of these loops right here. Okay, let's get rid of this. J, okay, this is gonna be column. Matrix at row I, column J. Wait, hold on. So I have all my values. So we need to, first of all, replace every item in row I with 0. That should do that part for us. Then we can do one of the for int j in map.get I for everyone in that list. K equals 0. K less than matrix dot length K plus plus. This is terrible. Like actually terrible. Okay. Let's try this real quick. Compile, please. Ugh. Yeah, okay. I'm really close. I'm really close to solving this one. Okay. If map.get I.size greater than 0, then we want to do this. So only if there was a 0 in this row, then we can do that. I don't know what this one was closing here. This one's closing this right here. Sweet. Okay, so that's done correctly. Now, this one should take care of our... Hey, let's go! TLE, because of the println. No TLE, let's go! So terribly slow, man. So terribly slow. Okay. That's that. I, in fact, cannot solve this next question in a minute, but let's just do some theory crafting. We somehow... What if we did a level order traversal, right? Level order traversal. And we know that the tree is aside from the root is always going to be symmetrical. So root is always might be confusing to use on 2. Oh goodness, your constipation. I haven't seen you in a while. Oh goodness, it sounds like I need to go to the doctor. How's it going? Because I'm thinking you do a level order traversal, and you maybe use a also use a stack maybe. Stack, pop off half the traversal. Push half of the traversal into stack. Then pop off and compare. So what have you been up to? It's been a while. At least not if I understand it properly. Curious to see how you solved it. What's the hint saying? Left and right subtree must be reflections of one another. I don't know, man. That's probably how I would do it. It's not fast, because it utilizes a queue for the level order as well as a stack for the comparison. But I mean, it'd be done in O of n time. Where n is just the number of nodes in the tree. Okay. Goodness. Try to do binary search data for a week and never again. Why though? Come on, it's you just barely were starting to get out of that like nasty grind period where you just don't understand anything. Like I've been at this for what, 3-4 months now. I think I started back up in September, October. Can't remember, but you know, I'm at the point where I can pretty much look at a problem and have a general idea of how to tackle it. But it takes mirror the right side and check if it's the same as the left side. But still, screw it. You kind of need to do things like this if you want to, I don't know where you're at, you know, maybe you already have a job, maybe you don't need to suffer like this. But, you know, if you're looking for a job, then you're definitely gonna need something like this, because if you don't know what to do, how do you figure it out? That's a great question. I think for the most part in the beginning, I'd rely on these hints a lot, because these hints tend to be very helpful. They're written by other people, so those hints would definitely help me a lot. If I didn't understand anything at all afterwards, I'd just take the hit and go to the solutions tab and just look through somebody else's solution and try and re-implement it. That would definitely be a big help. Another thing that would help me a lot is just kind of brute forcing it, honestly. I just kind of sit there and bang my head against it. It's also nice to have other people in the room with you who are better at certain topics than you are. Because graphs, for example, my first couple graph problems that I solved, I had to get like my hand held through it. Because I had no idea what I was doing. But yeah, other than that, I mean, I've never relied on like YouTube tutorials and just how to solve these things. I've never really retained much information from those. So that's never really helped me. Graphs made you give up. Aw, don't do that. If I can be honest with you, graph questions are, to be completely honest, there's like a total of like 2, maybe 3 graph questions. Everything else is just those graph questions, but with different words. Because if not, we don't care. Oh no, I should have read the instructions. Because yeah, if you think about graphs, right, you can have, let me pull this aside real quick. There's 2 main ways that you can traverse graphs, right? You have a DFS and a BFS, so depth first and breadth first. You just have to remember that a DFS, depth first, will always use a stack. If you want to think about a stack because it goes up taller, or you know, it can sink down deeper. And a BFS can utilize a queue to do it. I'm looking for, this is not a great way to show these implementations, but I is N is the length of the dictionary right now. M is the length of, well, yeah, I could have optimized but didn't feel like it. So if you think about it, right, you can have 2 ways of representing things as a graph, right? You can have your adjacency list. You can have 1, 2, 3, 4, 5. And I much prefer working with adjacency lists to matrices because I just don't like doing 2D array traversals. And let's say 1 is linked up to like 4 and like 3 and 4. 3 is linked up to like 2. 2 is linked up to 5, and so on. And let's say the data structure here is the only thing that differs. The technique for doing a DFS and a BFS is exactly the same. Do you know about Morris traversal, and is it underrated? Honestly, I have never heard of a Morris traversal. I don't know what that is. So yeah, quite literally all you do is, let's say you're starting at 1. You basically add node 1 to your queue. So I'll even write out the steps. It's fairly simple. Add the number 1 to the queue. And then what you do after that is just say, hey, grab the first number off the queue. Use it as the index in the matrix, in the list. Add everything at that index. And that's really it. And you just rinse and repeat, and eventually you will traverse the whole graph. So you take 1, you add 3 and 4. Then at the front of your queue is now a 3. You pop off 3, you look at index 3. Okay, well there's a 2 here. So you add that into there. Then the next one in your queue would be a 4. And you keep doing that over and over and over until you just done. Same thing with a stack, except the order ends up being slightly different. So, yeah. I think the most difficult thing is to just not be intimidated by these questions. My first Google question was like a stupid difficult graph problem. Yeah, it's honestly, graphs are very, very intimidating, but once somebody showed to me really, the fact that it's literally the exact same thing. And let me show you something else here, right? Let's say you have your adjacency matrix, right? The one that looks more intimidating than a list. Okay, well that's a weighted graph. I needed this right here, graph theory representations. So let's take a look at this image right here. Undirected graph, directed graphs are their own thing. You're gonna have to do something else about that. So if you look at this, right, all this is showing you is which nodes have a connection to which node. So for example, let's say you start at node A, right? What you do is you treat that again as an index in the matrix. So let's say you put A in the queue, you popped off A, you want to add on everything that A is connected to. Well, is A connected to A? No. Is it connected to B? Yes. So you add a B into your queue. You add a C into your queue because it's connected. You add a D, but you don't add an E. Then you pop off the next element. Your next element was B. So you use B as an index in the matrix, and once again add everything that it's connected to. The thing about these is, the way that I usually do it, is you need to keep track of which nodes you've visited so you don't end up going infinitely. The best way to keep track of just where you've been is to just utilize a set. So for example, I pop off A, add A to my set of visited values, and then add everything from here. And let's say you're searching for, let's say if A has a path to like C, I don't know. So your queue consists of A, then you pop off A, add A to the visited set. You add B, C, and D to your queue, you go to B. Okay, well, is B the one we're looking for? No. So you add D to your queue again, and then you add E. Then you go pop off the next one, which is C. Is C the one you're looking for? Yes. So you can return true. Every single graph problem, okay, well not every single one, but like 99% of the ones I've seen, will utilize a DFS or a BFS on either one of these or one of these representations. And that's all there is to graphs. It's as easy as that. It's just traversal by utilizing a queue and or a stack. Easy. That's all it is. It's obviously going to take practice. One question that I would highly recommend for practice on this is, let me see if I can find it. Number of islands. This one is a slightly different version of a BFS. It's done using recursion. But this is the first, yeah, I even wrote a note here, first graph problem I ever solved. So number of islands is a great practice problem for this one. I'll send that one in. Let me go back to my problems because I want to look through the ones that I have solved that are linked to graphs. Give me topic. I'll send in a few graph problems that are good for practice. Oh, it's in this session that I've only solved one. But yeah, let me see. Let me go back to all of them. Yeah, there's no real easy graph problems. But for example, largest island area. Yeah, for sure. I'm happy to help because I know how much of a struggle this has given me. I guess the other type of graph problem would be something like this, where it's number of islands. This is the only one that I'd say differs, because here you're looking at it top down, not from the side. So all this one is pretty much is something along these lines, where you want to basically find how many distinct islands there are, And every time you find a 1, it's considered an island, and every 1 that's attached to it is also considered an island. So all we're doing is, if you think about a BFS, it's called a, I don't think Americans use the word breadth, just kind of like width or like spanning out. So if you look at it, we're starting at wherever we found the 1, and then we're just checking to the left, to the right, to the left, up 1, down 1. And every time we do that, if we're still in bounds, so if we're out of bounds, we return a -1. However, if we find another 1, we know that we can continue searching. So we update that to a 0, which what the 0 does just means that, hey, when we go back, we won't end up in an infinite loop. But yeah, that's... I wish I could find more good graph problems. Let me see if I can hop on LeetCode real quick. And see if I can find a couple good problems. Just keep at it, man, honestly. That's all I can say. Like, dynamic programming, I can't really say much about. I've been avoiding it like wildfire. Because... screw dynamic programming. Pretty much, my idea behind that one was if I get dynamic programming, I'm going to try and brute force it for long enough to where I don't have to solve it. And I can get away with saying that I made an effort. Hash table, DFS. Is there anything for just straight up graphs? Greedy, graph, there we are. Prerequisites indicate that you must take the course. Oh, yeah, I think this would be a good one. This is what I meant regarding did I pass an interview yet? I've gotten 3 offers. I ended up not taking any of them. So I dropped 2 to take 1, then had some things to figure out with the other one, so pretty much ended up not taking either one. Actually, this one might be a bit more difficult, but honestly, just practice the graphs. Binary search has a much easier bank of problems than LeetCode does. But yeah, I finished my Google interview I think last Tuesday. Finished my Microsoft one yesterday. Google, not entirely sure about. Microsoft, I'm feeling pretty good about, to be honest. I'm hoping to get an offer from them because Microsoft's kind of been where I've been aiming from the start. So. I'm just looking for like an SDE position, honestly. If I could get, like, I'm looking for SDE ideally, pretty much, hopefully I'd be looking for, yeah, Microsoft's pretty nice. Looking for backend, ideally something to do with like cloud would be cool. Just because it gives me the experience to, in the future, pretty much have cloud technologies on my resume. I don't think Microsoft has their own cloud service, if I'm not mistaken. I know Google and Amazon do. So, you know, is it Microsoft Azure or Google? Hold on. Yeah, Microsoft Azure, they do. Google's is Firebase. So yeah, I mean, having Microsoft Azure on my resume would be still pretty nice. Yeah, I believe so. Granted, I don't think it's as popular as the other two, but... Alright, I think that's gonna be it for me for today. I hope my explanation of graphs kind of made sense at least. I hope it, you know, helped you to potentially not give up on graphs. Once you see them as just as what they are, just a simple way to represent connections, rather than, honestly, it helps me to not visualize them as these nodes that are connected to one another. I just visualize them quite literally as this, or like this kind of array, or this kind of array. That's all there is to it. But yeah, that's gonna be it. Oh, hold on, I can show this off, I think. It's a little broken at the moment, because I was working on adding attacking animations, but it's our in-progress team project for one of our courses. Yeah. Goodness, I wish I could get rid of the... Is there a way for me to very quickly get rid of the attacking section of it? I think I should be able to. I made sure to make this modular. There we go. uncomment this whole block. Ooh, he is a little broken. Why is he broken? You know, what did I even do to break him like that? Oh, I uncommented the wrong block of code, that's why. I think it's just... he's so powerful he's floating. Yeah. It's been a pretty fun project to work on. There we go. Got animations here and there. Bit of a dynamic camera. Got wall hangs, wall climbs. Whole lot of these dudes. We're still working on the attack section of it, but screw Java. No, it's all done in JS with just like an HTML canvas. Java is, I think, not the language in the slightest to do this in. But yeah, we're working on it with a team of 4, so the player currently is absolutely none of my contribution. Though these little dudes on the ground are. Very, very handsome little boys. Alright. They just kind of sit down, they waddle. Currently can't hurt you because there's no damage system, but yeah. Yeah, no, JS is a much nicer language for working with things like this. Genuinely, the only reason I use Java for algorithms and data structures is because I've gotten used to it. Alright. But yeah, that's gonna be it. Thanks everyone for stopping by. Hopefully we all learned something. I learned that I don't in fact know how to check if a tree is a symmetric tree. But yeah, that's gonna be it. Thanks everyone for stopping by.